Welcome to Rges Algebra 1. This is lesson 22A, and we're looking at sections 9.7 and 9.8. Now, we've been doing this brief chapter, has to do with scientific notation. We've talked about using that for very large numbers with positive exponents and very small numbers with negative exponents. Now, today we have, we're going to look at problems involving numbers and scientific notation. So these would be word problems using this skill. You will be doing 1 through 20 all, and I will step through the example problem and the first two problems with you. For the example problem, it has to do with the Louisiana Purchase, and it says in 1803, when Thomas Jefferson was president, the United States purchased about 5 times 10 to the 8th acres of land from the French for $15 million. About how much per acre did the land cost? Now, the first thing we need to recognize is what we're asking for. We're asking for the cost per acre. And in a problem like this, you will almost always, probably always, understand what to divide by what by the question. It says about how much per acre. The per means it's going to be in the denominator. It means for every acre, how much. So about how much per acre did the land cost? So we're looking for the cost, and that's the numerator. So the cost that he gave me was $15 million. Now we can write this in, I could do it this way. I could do 15 million would be hundreds, thousands, millions. So that would be 10 to the 6th. Or that transfers to 1.5 times 10 to the 7th. Okay. So 1 million is 10 to the 6th. So that's going to be my numerator. That's the cost. The denominator is, it says 5 times 10 to the 8th acres. Now again, we'll go ahead and we don't need to transfer that because the decimal's already right there. So we'll just say divided by 5 times 10 to the 8th. Now, how do we do this? Recall from our last time, what we would do is we would take 1.5 divided by 5, which would give me 0.3, and we're going to subtract, crossing out my ones there. 7 minus 8 is 10 to the negative 1. Now we want to put this in a better form, so we're going to, of course, we want the decimal there, and that would be times 10 to the negative 1. I'm just rewriting again just this part. Okay. Right here is going to rewrite as that, because this negative means that this will be a smaller number, which it is when it's 0.3, and then you carry down this. Again, you can do this in your head or you can do it on paper, and then you can combine that and you go 3 times 10 to the negative 2, and that is my answer. Okay, 10 to the negative 2 would be 3 cents if I'm interpreting this into something I want to understand. My decimal again would go over 2 places there. 3 cents per acre. So here's my mathematical solution. Here's my interpretation. So let me go over 2 more problems with you, and that should be enough, I think, on this. The next problem says, and I do ask you to do this, go ahead and repeat it by yourself, and only check when you're finished after you've watched me go through it once. In 1980, the national debt of the United States was about $790 billion. The 1980 census showed 226,504,825 people. How about how many dollars per person? So what are we asking? We're asking dollars per person. So we take our dollars first and divide by people. The dollar is 970 billion. Now billion, 100,000, million, billion. So it's billion is going to be just to get to 1 billion, right? So we're going to have times 10 to the 9th. Now we're going to rewrite this. Okay, I would hopefully have a little more room here. I think I can squeeze it in. Let's see. This would be 9.7. That would be times 10 to the 2nd, right? Because I want to make it a larger number, times 10 to the 9th. So I'll just go ahead and write both those in, 10 to the 2nd. All of that rewrites the 970, and then we're still times 10 to the 9th. So altogether, that would be 9.7 times 10 to the 11th. Now, what do I do for the denominator? It says very large number, so we'll go ahead and write all that. 2.26. Okay, I'll just round it, actually. And then if we count over, we're making that a large number, so we'd have to multiply it by a positive exponent, and we've moved it over 8 places. So I'm just going to round it like that. 2.26 times 10 to the 8th. So I'd get out my calculator. I would do this division. And then I would subtract, and that would be times 10 to the 3rd. And because this has already got the decimal in the right place, we're finished there. Now, when I go to then interpret this and put it into a reasonable answer, 10 to the 3rd is going to be pushing it to the right, making a larger number by 3 decimal places. So this would be $4,290 per person. Now, their answer was $4,280. And if you get close like that, that's fine. The reason it was off is because I went ahead and just rounded that. And then let's look at the next problem. This will be our last problem on this. The problem reads, the total area of the world's oceans is about 360.928 million square kilometers. The total volume of water in the oceans is about 1.32 billion cubic kilometers. The average depth equals the volume divided by the area. What is the average depth? So they tell me they want you to take volume divided by area. And so the total area, let's see, let's get volume first. The volume is 1.32 times 10 to the billion, 10 billion, I'm sorry. What am I saying? 1.32 billion cubic kilometers. Okay, so we are going to, a billion, that's what I'm trying to talk about, 100,000 million, that would be 10 to the 9th to get to billion. Okay. And then the 360.928 million. Million is 100,000. To get to million, we have 10 to the 6th. So we will go ahead and divide that. I'm going to go grab a calculator and then do some interpretation. Actually, first we'll go ahead and rewrite the denominator. We'll have 1.32 times 10 to the 9th over, I'm going to round it, 3.61. I'm making it a smaller number by 10 to the 2nd, or to go from the scientific notation. Let me write that better. Okay, so I'm going to go 3.61, then that would be times 10 to the 2nd times 10 to the 6th, that'd be 10 to the 8th. We're going to go ahead and do that division, and that'll be times 10 to the 1st. Let me go grab a calculator. So that answer would be, doing this division over here, the answer would be 0.366, but I don't, times 10 to the first, doing this, but I don't want to leave it in that form. I want to convert that, of course, over to 3.66 times 10 to the minus 1 times 10 to the 1. That would be times 10 to the 0 or 1. So there's no times there. Let's see. So let me just make sure you're following that here. This would be going to a smaller number, so that would be times 10 to the negative 1, moving it over one place, times the 10 to the first, there. These eliminate one another, and this is the answer. Now that's in kilometers. Then they ask me, what is the average depth? 3.66 kilometers. That's the answer. And how many meters is that? Well, a kilometer is 1,000 meters. So that would be times 1,000. 3.66. What is 1,000? 10 to the third. Okay? For meters. So let me just make sure we're understanding here. Okay. If we're going to the thousands place, if we say 7,000, that'd be times 10, that would be times 10 to the third. Millions is times 10 to the sixth. And billions is times 10 to the ninth. Okay. Now, let me look with you for a minute on the next section, which is your review, and see if there's anything I want to cover with you. This little explanation he's doing at the front of the chapter review might be helpful to you. He's just basically saying that if we are taking exponents and we're raising it to a power, for instance, 7 squared to the third, if we're doing power is an operation, right? Exponentiation. We are going to go one operation down and we will multiply. Whereas if we are doing 7 squared times 7 cubed, our operation is multiply, and we're going to go down one more operation to know what to do with the exponents. So he's showing that kind of relationship, okay? If we say 7 squared, let's do something better than a number, a squared plus a cubed, our basic operation is addition, and one down from addition, we do nothing. We don't do any operation unless they have the same. We can only combine these if they have the same exponent. Remember, like terms there. Okay, let me look at anything else I might want to talk about. Okay, when we actually get into the problems, I want you to go ahead and skip number 1 and 2. You can just go straight into the problems, do all of 3, 4, and 5, and 6. Okay, so do 3 through 6 all parts. Now, but do recall that anything to the 0 power is 1. Anything to the first power is whatever you began with, like 7 to the first power, 7. Recall that a negative exponent is the same as putting it in the denominator with a positive exponent. By the same token, if you had something like a negative exponent in the denominator, that's the same as putting it in the numerator with the positive exponent. What else to say? And then let's just review one last time. If we had x to the a raised to the b, that's the same as x to the a times b. If we have x to the a times x to the b, that is the same as x to the a plus b. If we have x to the a over x to the b, that is the same as x to the a minus b. So these are my 3 basic rules that you've been working with when you were in the exponent chapter. All right, you should be good to go.